This is SpaceTime, Series 25, Episode 87. Coming up on SpaceTime, NASA to send 2 more choppers to Mars for its sample return mission. America's top secret space shuttle sets a new record. And China expands its space station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA says its Mars Ingenuity helicopter has been so successful, 2 more will be built and sent to the Red Planet in order to help with the upcoming Martian sample return mission. This joint NASA-European Space Agency mission will see an Earth return orbiter launched in 2027 with a sample return retrieval lander to launch the following year, with samples from Mars being returned to Earth in 2033. It's all moved on a bit from the original plans, which called for a separate fetch rover to land on Mars and collect samples, which are currently being drilled and assembled by NASA's Mars Perseverance rover in Jezero Crater. Those samples would then have been returned by the fetch rover to a Mars ascent vehicle, which would have descended to the surface aboard a sample retrieval lander. The lander would then act as the launch pad for the Mars ascent vehicle, which would fly up and rendezvous with the Earth return orbiter for the return journey back home. These new plans will see the Mars Perseverance rover replace the fetch rover and directly load its samples onto the Mars ascent vehicle. And that means there's no need for a second lander or the additional rover. NASA's Associate Administrator for Science, Thomas Abuchan, says the changes were possible because of the reliability success of Perseverance and the amazing performance of Ingenuity. It means there's now room on the sample retrieval lander for 2 sample recovery helicopters, based on the design of the 1.8 kilogram Ingenuity, which has performed some 29 flights on the Red Planet surface since its arrival attached to the Perseverance rover in February last year. These new helicopters will provide a secondary capability to retrieve samples on the Martian surface. To do this, the new versions will be fitted with wheels and grappling arms. Each helicopter will be designed to lift 1 sample tube at a time, making multiple trips back and forth. A European Space Agency-built sample transfer arm will then robotically place the sample tubes from the Perseverance rover into a special orbital sample container mounted inside the Mars Ascent vehicle. The Mars Ascent vehicle will then launch from the surface of the Red Planet into orbit, where it will dock with ESA's Earth return orbiter for the journey back home. During the journey back, those samples will be transferred from the orbiter into an attached NASA capture, containment and return system. That will parachute back down to the Earth's surface, keeping its precious cargo free from Earth contamination. So far, Perseverance has collected 11 rock core samples together with 1 atmospheric sample. If all goes well, up to 30 samples will be collected by 2031, when the Return to Earth mission would launch from the Red Planet with a scheduled arrival on Earth in 2033. Which I guess gives us a timeline for when the first humans will travel to Mars. This is SpaceTime. Still to come, America's top secret space shuttle sets a new record, and China expands its space station. All that and more still to come on SpaceTime. America's top secret space shuttle has set a new record. The clandestine X-37B has shattered its own orbital mission duration record of 780 days in space. The reusable spaceplane, one of 2 built by Boeing and based on NASA's famous space shuttle fleet, was launched on its current mission, known as OTV-6, back on May the 17th, 2020. The delta-winged X-37B were originally developed by NASA in 1999 to be launched from the payload bay of NASA's space shuttles and then undertake their own independently programmed missions after release. The project was taken over by the Department of Defense in 2004 and is now operated by the US Space Force. The X-37B's ability to suddenly change its orbit mid-flight makes it difficult for adversaries to track, further adding to its mystery, since it can undertake different missions at different altitudes and different orbital inclinations. ODV-6 was launched aboard an Atlas 501 rocket from the Cape Canaveral Space Force Base in Florida, carrying more experiments than any other X-37B mission so far. While most details of the flight remain highly classified, 2 NASA experiments were included in the payload. One is evaluating the reaction of different materials to long-term exposure in space, while the other is studying the effects of ambient space radiation on seeds. Among the other science packages on the flight which aren't classified is an experiment transforming solar power into radio frequency microwave energy, which is then being transmitted as usable energy down to Earth. The missions also deployed the 136-kilogram Falconsat 8 experimental satellite, which itself is carrying 5 experimental payloads, including a magnetogradient electrostatic plasma thruster propulsion system, a new metamaterial antenna, which is compact but still provides phased array-like performance, a carbon nanotube experiment using RF cabling with carbon nanotube braiding flexed using shape memory alloys, a new flywheel-based attitude control and energy storage system, and a new camera and GPS system. The rest is classified. This is SpaceTime. Still to come, China expands its space station, and we take a look at the giant star Antares, Barnard star, the second nearest star system to the Sun, and the annual Perseids meteor shower, as we explore the August night skies on Skywatch. China has launched the second module of its new Tiangong space station. The 23-ton Wentian module was flown aboard a Long March 5B rocket from the Wenchang Space Center on Hainan Island in the South China Sea. It successfully docked onto the Tianhe core module of the space station 13 hours after launch. A third module called Megtian is slated to join them in October. The 3 modules will form the core of Beijing's new manned orbital outpost, which the Chinese government claims will be used for scientific research. While the Tianhe core module provides taikonauts with living accommodation and the space station's control, power and life support systems, the 2 new modules will provide laboratory space for the orbiting outpost. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for August on Skywatch. August is the 8th month of the year in the Julian and Gregorian calendars. It was originally named Sextilis in Latin because it was the 6th month of the original 10-month Roman calendar under Romulus in 753 BCE when the year started in March. It only became the 8th month when January and February were added to the start of the year. In the year 8 BCE, it was renamed in honor of the Roman statesman and military leader Augustus, who had achieved several military victories, including the conquest of Egypt during the month. Okay, turning to the heavens, and the constellation Scorpius the Scorpion is high overhead this time of year, covering almost a third of the August night skies. At the heart of Scorpius, located some 470 light-years away, is the red supergiant Antares. A light year is a distance of about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Red supergiants have the largest diameters of any known star. They evolve out of main sequence stars with more than 8 times the mass of the Sun. A main sequence star is a star fusing hydrogen into helium in its core. When stars stop fusing hydrogen into helium in their core, the balancing act between gravity pushing a star's mass down towards the centre and energy from nuclear fusion in the core pushing outwards ceases, and gravity wins, causing the star to begin to collapse inwards, crushing the stellar core until the increase in pressures and temperatures trigger helium fusion. At the same time, a shell of hydrogen around the core begins to fuse, causing the star's outer gaseous envelope to expand out into a bloated giant. And now, being further away from the core, the stellar surface starts to cool down, becoming redder in colour. while Sun-like stars will become red giants. Those that are far bigger, 8 times or more the mass of the Sun, become red supergiants. Supergiants will fuse all their core helium into carbon and oxygen within just a few million years. They'll then begin fusing this core carbon and oxygen into progressively heavier and heavier elements until they eventually begin to produce iron in their core. Now, no star, no matter how massive it is big enough to fuse iron into heavier elements. And so then the star will collapse catastrophically in what's known as a core collapse supernova, an explosion bright enough to outshine an entire galaxy. The end result of this core collapse supernova will be the creation of either a neutron star or a black hole, depending on the progenitor star's mass. The name Antares means rival of Mars, and indeed when they're close together in the sky, they do look very similar. Antares, or Alpha Scorpii as it's sometimes called, has some 12.4 times the mass and an incredible 450 times the diameter of our Sun, and is one of the largest known stars in the universe. Antares is so big that were it placed where the Sun is at the centre of our solar system, it would engulf all the inner planets, Mercury, Venus, Earth and Mars. Its outer surface would reach almost as far as the orbit of Jupiter. Antares is a binary system. There's a companion star orbiting with it called Antares B, a massive spectral type E blue-white star, at least 7.2 times the mass and 5.2 times the radius of the Sun. It's located about 224 astronomical units beyond the primary star. An astronomical unit is the average distance between the Sun and the Earth, about 150 million kilometres or 8.3 light minutes. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're closely followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive of all stars are spectral type M red stars, commonly referred to as red dwarfs. Now, each spectral classification is further subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now, put all that together, and our Sun is a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types LT and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red dwarf stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or 0.08 solar masses. Located near Antares is the spectacular globular cluster Messier 4, or M4 for short. Named after the 18th century French astronomer and comet hunter Charles Messier, it's one of a catalogue of 103 fuzzy objects which weren't comets, and so were of no interest to Messier, and so he made a list of them, so he didn't waste his time looking at them. Other astronomers have since added further celestial objects to the catalogue, bringing the total to around 110. Located some 7,000 light-years away, Messier 4 can be seen through a pair of binoculars, making it one of the closest globular clusters to Earth. Globular clusters are densely packed spheres containing thousands to millions of gravitationally bound stars, which it's thought were either originally all born at the same time in the same stellar nursery, or are the surviving cores of galaxies that have been cannibalized by larger galaxies. They're almost always found orbiting the halo of galaxies. The Milky Way has about 150 of them, and they're all usually very ancient, some dating back to around 12 billion years. Located just below the sting of Scorpius are two open star clusters, M6 and M7. M7's the nearer of the two, located about 800 light-years away, while M6 is a more distant 2,000 light-years. Open clusters are less densely packed than their globular cluster counterparts, with the stars inside them less gravitationally bound and more prone to drifting away over time. Another open star cluster in Scorpius is NGC 6231, located about 6,500 light-years away, just near the star Zeta Scorpii. NGC 6231 is a bright open star cluster containing around 120 stars, including a significant population of highly luminous supergiants, numerous white-yellow stars, and at least 2 Wolf-Rayet stars. Wolf-Rayettes are extremely luminous evolved stars reaching the ends of their lives. Having run out of hydrogen for core fusion, they're no longer on the main sequence and are instead fusing progressively heavier and heavier elements in their cores. This causes them to have surface temperatures of up to 200,000 degrees Celsius, and such extreme temperatures generate powerful stellar winds. Just behind Scorpius is the constellation Sagittarius, the half-man, half-horse of Greek mythology. And as we mentioned in last month's Skywatch, the centre of the Milky Way galaxy is found in Sagittarius, roughly 27,000 light-years away. The name Sagittarius can be traced back beyond the Greeks to the ancient Mesopotamian archer god Nergal. Sagittarius is known for its many nebulae and clusters, more than any other constellation. One of the largest and brightest is the globular cluster M22, big enough to be visible to the unaided eye. Located about 10,600 light-years away near the galactic bulge, M22 is more elliptical than most globular clusters. It's located just south of the ecliptic, the plane in the sky upon which all the planets orbit the Sun, and it contains over 70,000 stars, covering an area of around 100 light-years. It also contains at least 2 black holes, and is one of only a handful of globular clusters known to contain planetary nebulae, the puffed-off outer gaseous envelopes of dead Sun-like stars. Located in the sky next to Scorpius in the west and Sagittarius in the east is the constellation Ophiuchus, the healer or serpent bearer, often portrayed as a snake coiled around a man. In Greek mythology, Ophiuchus raises Orion from the dead after he was bitten by Scorpius. Ophiuchus contains several star clusters and other interesting features, including Barnard star. Barnard star is the second nearest star system to the Sun, beaten only by the Alpha Centauri triple star system. Located some 5.9 light-years away, Barnard star is a spectral type M red dwarf, about 0.144 times the mass of the Sun. Our Sun is around 4.6 billion years old. At between 7 and 12 billion years of age, Barnard star is considerably older than the Sun and may be among the oldest stars in the Milky Way galaxy. It's lost a great deal of rotational energy, and its periodic slight changes in brightness indicate that it's rotating about once every 130 days. By comparison, our Sun rotates roughly once every 29 days. Given its age, Barnard star was long assumed to be quiescent in terms of stellar activity. But in 1998, astronomers observed an intense stellar flare, indicating that Barnard star is indeed a flare star. Flare stars are variable stars that can undergo unpredictable dramatic increases in brightness lasting a few minutes. It's believed that the flares of flare stars are analogous to solar flares in the Sun, in that they're generated by stellar magnetic energy stored in the star's atmosphere. Lying just to the west of the Scorpion is the constellation Libra, the Scales. In Greek mythology, Libra represents the claws of Scorpius the Scorpion. However, the Romans considered Libra a distinct separate constellation from Scorpius and thought them to be the scales symbolizing the equinoxes, the times of the year in March and September when the Earth gets equal lengths of day and night. That's because 2,000 years ago, when all this was made up, the Sun moved into Libra at the time of the September equinox. But due to precession, as the Earth's spin axis wobbles in direction, this point in time has now moved into the adjoining constellation of Virgo. If you look to the south in the Southern Cross, that's the constellation Centaurus, another half-man, half-horse mythical beast. Centaurus was the teacher of many of the Greek gods and heroes. He was placed among the stars in the heavens after accidentally being killed by a poisoned arrow fired by Hercules. Close to the pointer star nearest the Southern Cross, Beta Centauri, lies NGC 5139, Omega Centauri, the largest and brightest globular cluster in the visible sky. Because of its brightness, the ancient Greek mathematician and astronomer Claudius Ptolemy originally thought Omega Centauri was a star. It has a diameter of more than 150 light-years and contains an estimated 10 million stars, giving it some 4 million times the mass of our Sun. Located some 15,800 light-years away, Omega Centauri is another very ancient globular cluster, around 12 billion years old. and it contains many so-called population 2 stars. These are the second generation of stars to have formed, and were created directly out of the remains of the very first stars in the universe. Stars in the core of Omega Centauri are so crowded, they're estimated to average only 0.1 light-years away from each other. And that compares to the nearest star to our Sun, Proxima Centauri, which is some 4.2 light-years distant. Located close to Omega Centauri in the sky is the giant lenticular galaxy NGC 5128 Centaurus A, which we see looking like it's split in half by a thick band of dust. The galaxy was discovered in 1826 by astronomer James Dunlop from his home in what is now the Sydney suburb of Parramatta, a time long before the bright lights of a modern city would make such a discovery impossible. Located some 13 million light-years away, Centaurus A is one of the strongest radio sources in the sky and is thought to be the result of a merger between an elliptical and a spiral galaxy. It can be easily seen using a pair of binoculars, but you'll need a telescope to make out its spectacular dust lanes. August is also the time of the peak of the annual Perseids meteor shower. The meteors are the debris trail ejected by the comet Swift-Tuttle as it travels along its 133-year orbit through the solar system. As its name suggests, the Perseids radiant, that is the point in the sky from which the meteors appear to originate, lies in the constellation of Perseus. The Perseids are one of the oldest known meteor showers, with early Chinese historical records of its activity going back almost 2,000 years. They're active between July the 17th and August the 24th, with a peak on August 12th with around 60 meteors an hour being visible. The Perseids are very bright and fast-moving meteors, travelling at speeds of 59 kilometres per second. They're best seen between midnight and just before dawn, producing long, bright trails and some fireballs. Most Perseids burn up in the atmosphere at altitudes of over 80 kilometres. They're best seen from the northern hemisphere, so for southern hemisphere sky watchers, look to the north with the radiant below the northern horizon. And now joining us for the rest of our tour of the August night skies is Jonathan Nally, the editor of Australian Sky and Telescope magazine.
It's August, so the Milky Way is dominating the evening sky this time of the year. If you go outside in the mid-evening, early evening during August, you'll find the Milky Way, which of course is our galaxy just seen from the inside. You'll find the Milky Way stretching all the way across the sky from the northeast down to the southwest. And the centre of the Milky Way, in the region of Sagittarius, is pretty much directly overhead for those lucky enough to live at the latitude of Sydney in the southern hemisphere, and which means we've got brilliant views into the heart of the galaxy. And that's one of the reasons why a lot of big observatories were set up down here in various countries in the southern hemisphere, in Australia, South Africa and Chile and those sort of places, because astronomers are very interested in what goes on in the centre of the galaxy because it's the nearest galactic centre that we've got. So it makes a lot of sense to study it from down here. Our friends in the northern half of the planet don't get to see much of this part of the sky high up, at least from, say, North American latitudes or UK or through Europe. It's either very low on the horizon or even below the horizon. They never see it if you're that far north. Down in the south for us, you can see the Southern Cross at the moment. It's in the southwest, lying on its right-hand side, about halfway up from the horizon in the mid-evening. The cross itself is also within the band of the Milky Way, so this Milky Way is stretching across the sky. And going northwards along the line of the Milky Way, you get lots of other famous and interesting constellations like Centaurus, Scorpius, Sagittarius, and also down in the south, detached from the Milky Way, sort of, if you've got Milky Way going there, you've got a blank spot, and then down below it, down towards the horizon, you've got the two famous Magellanic Clouds, which are the nearest sizable galaxies to our Milky Way. And you need a fairly dark sky to see these things. If you're looking in city skies, you might not see them because they are pretty faint. And
they look like fuzzy clouds.
They look like faint fuzzy clouds. Yeah, very sort of indistinct. They don't have sharp edges or anything. No. It's better off, in fact, if you look out the side of your eye, what astronomers call averted vision. Don't look directly on at them. Just sort of try and look out the side of your eye and you get a better view. That's because at night time, the light receptors in the centre of your eye aren't really good at low light levels, and the ones on the side of your retina are better at low light levels. So use averted vision, look slightly out the side of your eye, and you can sort of make them out a lot better. If you're stargazing for long enough during the evening, in fact, as the night goes on and the Earth is turning, you'll notice that the band of the Milky Way will appear to shift from stretching across the northeast to the southwest. It'll appear to shift more around to the north and west, and it'll be getting lower and lower in the sky. That's as the Earth is rotating rotating, of course, until by around about 4 o'clock in the morning, you'll think, oh, where's the Milky Way gone? It sort of seems to have disappeared. Well, it's still there, but you probably can't see it because it's laying sort of flat all the way around the horizon. And as the night continues to go on further, then you'll see the other half of the Milky Way starting to come up in the east. So if you are a morning person, there is plenty to see in the eastern half of the sky in the hours before dawn. This includes the fabulous constellation Orion, the Hunter, with its bright stars Rigel and Betelgeuse. And it's very easy to see a group of 3 stars in a row, which form the belt of the mythological figure, the Hunter, Orion the Hunter. A little way around to the right or the south of Orion, you'll find Sirius, which is the brightest star in the night sky. And a little further around to the right, you'll come to another bright star called Canopus, which is the second brightest star in the night sky. This time of year, when you're sort of up early and about before dawn, or you stay up really late and you see some of these constellations coming up, you know summer's on the way, because these, for us in the southern hemisphere at least, they're summer constellations. For our friends in the north, they are winter constellations. So it's really showing that the end of the year, end of the calendar year is coming near, and some of these brilliant things to see up in the night sky are not too far away, only a few months away now. Now, turning to the planets, and for once I'm glad to be able to say that we're heading to pretty good conditions to see the planet Mercury. Mercury, a lot of the time, stays very close to the horizon, either after sunset or just before dawn, and so it can be hard to see, not only because it might be lost in the glare of the twilight and the dawn light, but also because being so low down, if you've got buildings or trees or anything in the way, then it's going to block the view, of course, and you won't see it because most of the time it stays pretty close to the horizon. But at the moment, you'll be able to see it in the west after sunset. It just looks like a brightish sort of star. If you take a look on August the 4th, you'll find it fairly close to a bright star, a star called Regulus, which is the brightest star in the constellation Leo. The other inner planet, Venus, you'll be able to see that for the first week or so of August. It'll be low down on the eastern horizon before dawn. So you've got to be an early riser, look out to the east before the sun gets up, just as the sky is starting to lighten a little bit and you can see a bit of a dawn glow coming up. You should be able to see Venus big and bright, but fairly low down on the horizon, but getting lower every day. So by the end of the month, by the end of August, it will have become lost in the glare of the sun and it'll be out of view for a couple of months or a few months now. It'll pop back up. I think it's in December, and then we'll get another good view of it for the few months after that. Jupiter, planet Jupiter, big and bright in the evening sky. Look for it in the east after sunset. This planet will be at opposition next month in September. Now, opposition is when a planet and the sun are in opposite directions as seen from Earth. And what that means is that for someone here on Earth, when you're seeing the sun go down in the west, the planet's going to be rising up in the east. And there's nothing mystical or magical about that. All it basically means is that you've got the whole night then to look at it. Because as the sun goes down, the planet's coming up, you've got 12 hours or so, or 8 hours or 9 hours, depending on what your particular season is, to study this planet all night long, which is going to be really, really good.
Have you seen the brilliant James Webb image of Jupiter that's just been published?
Yes, I have seen that. I haven't had a good look at it yet, but it looks pretty good. And look, they'll get even better pictures as the months and years go by. But I've actually just written an editorial for the next issue of Australian Sky and Telescope magazine and about Webb and the fantastic things it's going to see. And the thing that most people are concentrating on, and fair enough too, is the views that it's going to give us of the far distant universe, both in terms of distance and time, looking back in time, the earliest galaxies. But I'm actually really keen to see what it's going to do, looking at our solar system and things that might be close to our solar system. So, for instance, new planets perhaps, planets that haven't been found that on the far outskirts of our solar system, Planet X, that sort of thing, or even just more sort of Plutinos, those sort of ones that are out there in the far distant reaches beyond Pluto and that sort of area, because where the James Webb Space Telescope being optimized for infrared will be able to pick up very, very cold things that don't give off a lot of heat, that are only shining in the faintest of reflected
so lots
light.
of brown dwarfs and exoplanets.
Brown dwarfs, exoplanets, and Pluto-like objects that are far out beyond Pluto.
Trans-Neptunians.
Trans-Neptunian things, yeah, all those sort of things. I mean, there are lots of them out there, and no doubt there are lots more to be discovered. So that's what I'm really looking forward to, because in a way, I'm just going to contradict what I was about to say. I was going to say that, there are a lot of those things out there we haven't really seen before, but we've seen things like them, just as looking back through time towards the Big Bang, we've seen plenty of other galaxies and things. And this is the thing too, that James Webb Space Telescope is both revolutionary, but I think it's more evolutionary. It's going to be doing pretty much the same kinds of things that have come before, but it's being far bigger and more modern and all that sort of stuff. It's going to be able to do those things a lot better.
So it's the improved resolution resolution you're excited about?
The improved resolution, the sensitivity of its detecting system. So you could have a telescope you could have two telescopes side by side, and they might be the same size and everything. But if one's got more sensitive detectors or receivers on it that can discriminate very, very faint signals, as scientists call them, from background noise and background interference, then that's what you really want. You want large size, which gives you ability to see detail, and you want high sensitivity to be able to detect faintness. That's what you really want. Because a lot of the things that astronomers are interested in are so far away that they are incredibly faint. And when you're talking about these galaxies right back towards the beginning of the universe, I mean, they're super faint, super faint. Just, sort of thing you could not even dream of seeing 30 or 40 years ago. So it's going to be able to do the same kinds of things that have been done before, but so much better. And that will no doubt bring lots and lots of discoveries. So, but I'm particularly interested in seeing what it's going to be able to pick up in our solar system and sort of not far beyond our solar system. Not necessarily because that's my particular main interest, but I think it's just an area that hasn't really been, what should we say, explored as much as it might. It's sort of more our backyard, and there's still lots to find out there, I think. So anyway, there we go. So I did see the pictures of Jupiter from Webb. Couple more planets to go. One more planet, really, Saturn. And so speaking of opposition, I was just talking about how, opposition is when a planet and the sun are in opposite directions in the sky, so it gives you lots of nighttime viewing. Well, Jupiter's opposition is going to be next month, September, but this month, Saturn reaches opposition on August the 15th. So great time to see Saturn. So around about that time of the month when the sun's going down, Saturn will be coming up over the horizon in the east. Now, to the naked eye, Saturn just looks like a bright, slightly yellowish coloured star out in the eastern sky. But if you get a chance to look through a telescope, even a small one, you will see its rings. And there's just nothing like seeing Saturn through a telescope, particularly for the first time. It's just one of those wow moments. Everyone just goes, wow, particularly when you stop and think, well, this is actually real. This is the sort of thing Galileo was looking at hundreds and hundreds of years ago.
I'm trying to
really
understand.
Trying to figure out what is this thing. Yeah, to him it seemed to be a planet that's got ears in it, which were the rings, because his telescope gave a very fuzzy view and you couldn't discriminate the rings to see what they actually really were. So, if you get a chance to look at Saturn through a telescope, maybe your friend or family's got one or there's an observatory nearby, please do. What else? Well, just finally, planetary oppositions and primetime viewing opportunities. Well, we've got a few more coming up later in the year. We've got Neptune will be at opposition in September and Mars in December. Now, Mars is the one that everyone's really interested in because Mars comes quite close to the Earth. Astronomically speaking, closer than the other ones do. Well, Venus actually does come closer, but you can't see a lot on Venus. It's just covered with clouds. But Mars is the one that amateur astronomers particularly really like to get a good view of. It comes around every 24 months or so. There's good viewing opportunity. This time won't be superb in terms of viewing because it's not going to be as close as it's been at other times, which means it'll look a little bit smaller. It won't be quite as big through a telescope. But nonetheless, let's keep our fingers crossed for some good viewing opportunities in December for those people who like Mars. And that's Stuart. Is the night sky for August.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel. And on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.